Hello, everyone. Welcome, and thank you for joining this session. And this is a Monday session. We used to have this what we call Monday paper reading, or invite some industry experts and share their experiences and latest framework they have been trying. And all those things, we used to do it 2-3 months back, at least a couple of months back. We are trying to bring that back. With that, there will be two regular meetups will be going on. One on Wednesday. It's mostly Wednesday one is mostly paper reading, research paper reading, which goes in depth in a particular paper for that week. On Monday, again, we want to bring in some industry experts and talk about a tool, framework, or interesting topic. Today's topic is about Internet of Agents. We have been hearing about the agents and agents, agentic AI, agents and agents framework. These are all the hot topics. And some of us who joined here might be having experience in building some sort of a RAG pipeline or some agents, using LangGraph or LangChain and then Crew AI. Now, those who are joining with that background, they will benefit a lot. And if you are coming from, say, basic building blocks of RAG meaning retrieval augmented generation, and then Gen AI, I'll try to give some brief overview, which might help you to understand some of the slides coming. So what is an agent? Without going too deep into that, agents must collaborate. Agents collaborate and then solve a problem. In Gen AI world, we are specifically talking about AI agents, collaborating each other and solving a simple or complex problem. That's a definition of agents, AI agents that we put forward. Right? And it is like, agents are like a team of experts solving a problem. In an enterprise setup, these agents could potentially solve a lot of workflow problems. Today, a lot of in the enterprises uses RPA meaning robotic process automation, and then many other ways to automate a complex workflow. As with the advent of agents and AI agents, we are seeing a momentum towards enterprises trying the agentic AI in solving these workflow problems in much more complete way, right? And as part of this agents and then RAG and Gen AI, we understand a lot of these things are probabilistic. That means when agents make a decision, when it makes a reasoning and understand the path to solve a problem, there is a probabilistic approach is followed there. Essentially, it's because of your agents are using LLM as one of the reasoning engine, right? So how does it, all these things in the probabilistic in nature and the agents communicating to each other or collaborating to each other, and all these things need a robust platform. So if you look back, agents platform like Crew AI and then LangGraph, and then many other platform like AutoGen, they're all solving the problem of collaboration and then underlying, workflow behind making the collaboration work on its own way. And more recently, you might have heard about Google's A2A protocol, right? Agents to agent protocol. That is also an attempt, to standardize, how agents communicate to each other, right? In the beginning, it was more of a specific, technology agents talking to each other. And then with so much of agentic framework coming in, Google is proposed a problem of solving an agent to agent. Could be different agents communicating to each other through the A2A protocol. So there is an aspect of the agent to agent communication, agent to agent protocol is coming, right? And then at much higher level, you have a semantic understanding between the agents, to collaborate each other. Then at the lower level, right, and that is where the Internet of Agents is going to come. There is an aspect of what is a transport layer is needed to be used. Traditionally, these protocols in MCP and then A to A. It probably using the existing HTTP or GPRC as a protocol behind the scene to make the communication work between agents. As you know, Cisco, when Cisco looked, first of all, I'm a technical leader at Cisco. I've been with Cisco for many years. And when the agent stuff came into the enterprises, one of the thing for Cisco is interested in making the agents work at scale is to look at how communication layer or transport layer behind the agents, and then how Cisco can play a role in terms of making it scalable, like the way DNS. Some of you are familiar with the DNS. Maybe knowing DNS is a distributed protocol, and it works at internet scale. It effectively exchange the domain name between different servers, right? With that experience, Cisco thought about, if agents are going to become a true entity in the world, then in the future, when agents need to communicate each other, perhaps it needs a scale at which something like DNS need to come in to exchange, DNS metadata. So in this case, agentic metadata between the different agents. And something similar to that internet scale architecture need to come in the play to make these agents work seamlessly across multiple platforms. So that's reason Cisco started this called Internet of Agents. So in summary, there are many layers. The industry is now, it's all evolving as we speak. We are all figuring out multiple layers of agents. And we are moving away from simple understanding of agents working together like in Crew AI. And then we are further exploring how agents are going to discover each other, how agents are going to identify each other when agents communicating. When I say agents in this meeting, I'm talking about AI agents, right? And how they identify each others and how they recognize each other and allow each other to communicate. So those are the problems at scale we need to solve. Okay. So the purpose of today's, our goal of today's meeting is to show some of the components being proposed. Some of them are in action. You would see open source implementation of different parts of this agent's communication. Some of them are specifications. I will show you both, and that gives you a good understanding of not only developing agents at a small level, but also allow you to think at a much bigger scale, right? Potentially, when internet is full with agents, these concepts and framework, and might help you to navigate this more clearly. So the Internet of Agents. What is Internet of Agents? Definition of Internet of Agents. It is a conceptual framework to some extent, and also open sourced framework from Cisco to allow what we call agents to communicate each other irrespective of the what we call syntactic protocol. So what we do at Cisco, we define 3 levels of layers in this agent's communication. One is called syntactic layer, other one is semantic layer, and third one is a transport layer. um, until now, we never thought about a transport layer is the biggest piece in the agent communication. We took it for granted. Yes, all these agents are communicate through HTTP or HTTPS under the library level, right? Crew A or LangChain and all. But the transport layer is very important. That's where the Internet of Agents, along with other components, will come and play. We are going to talk more about that. But before we do that, this diagram tells you it's an ensemble of a lot of agents need to be collaborating. In the future, you'll see personal agents, social agents, and then business to business agents. All these agents need to communicate, collaborate each other, right? And what is a core component of Cisco's Internet of Agents? Well, right now in the market, as you know, A to A is one of the what we call syntactic layer. The way we define A to A, MCP, and then ACP. ACP is agent, I think agent context protocol. So all these protocols allows the agents to communicate each other, right? And what is the core principles? Basically agents need to make decisions in a distributed, decentralized way. So that's one of the, you can say, core principles of building the Internet of Agents. The second one is when we want to compose a new agent. Now when we want to create a new agent, we want to compose from existing agents which is available. It is pretty much like if you're aware of object-oriented programming, we can compose a new object out of the existing objects. Similarly here, you should be able to compose new agents from the existing agents. Of course, semantic understanding. When agents wants to communicate with other agent, it should be able to communicate its context. It's sometimes memory, sometimes the protocols behind that. So the semantic understanding need to happen between the agents. So these are all some of the principles we need to take into account when you define the Internet of Agents framework, conceptual framework. Okay, let me pause here. Now in the last few slides, I tried to communicate what is Internet of Agents. And I was trying to talk about there are many layers to that in the agents space. One, I was saying syntactic layer, semantic layer, and transport layer. Please remember these three layers, syntactic layer, semantic layer, and transport layer. We are going to go into each of them. So there is a parallel to this, now that agents are becoming mainstream, as we are trying to define a new standardization and taking the agents to internet scale level. When I say internet scale level, I'm talking about, you guys know, so many IP addresses, so many DNS servers are there. It's seamlessly working now. So in the same way, we can think about this problem that we have seen this before in some perspective. If you talk about some of you are familiar with messaging systems. Messaging systems are, in the simplest way, right, allows one computer or one application to talk to other application, right? So the next few slides give you some idea about historical perspective of the messaging system. Then I am going to relate it to the current agents way of communicating. So this gives you some background, before we go into the Internet of Agents. So again, in your mind, to make it simple, what this session is about, take you to the transport layer of, and then where we are going to talk about how these agents can scale to the internet level, communication at scale. So our focus is again transport layer.
Hi, Krishnan. Sorry,
Yeah.
there are some questions in the chat that
Yeah.
maybe you want to.
Yeah. Let me pause and then. Okay. So basically the question is, what Cisco you mean by agent, so that we are on the same page. Yeah, it is same. Agents, the definition of agents are same. Only before I'm answering Ram Singh's question. The definition of agent is same. Agent is an autonomous entity which has a context, which has a model, and then it communicates to either tools to achieve something the React agents is defined, right? It basically gets the response stimulus from the environment, and it acts on it with the help of LLM reasoning, and then it respond back to that to the environment. So that's the agent. That's the same definition, right? And then I will go into that syntactic, semantic. I didn't say synthetic. I was mentioning about syntactic. Syntactic means syntax level definition. Semantics means in the how the agents understand each other. That is called semantic. And then transport is a underlying layer. I'm going to all these three things you're going to see more in deep in the coming slides, and we can also have a QA at the end. All right, thank you. So now in order to build that, what we call the transport layer, I need to give some introduction about the messaging. So the little bit of historical perspective, right? Messaging allows as you see in the slide, in 60s and 70s, and of course, the concept of communication, internet came up, and then computer communication came up, right? And then followed by that, application is trying to communicate to other application. Then IBM probably pioneer in that in the early stage of messagings. So you can broadly divide, some of us who are experienced now in Kafka and other things, if you go back, it comes to only three core areas. One, application wants to communicate to other application, either its own instance or different application. It uses a queue approach, it sends a message in queue, and other application picks up that message. It's called queue-based message passing system. And then followed by, as you see, IBM MQ was popular in that, seems like in 90s, IBM MQs were popular. And of course, behind that simple queuing mechanism, you do have other characteristics, right? Whether the queue needs to be persisted or it needs to be, reliability is to be maintained. All these are details of how the queuing-based messaging need to work. And in the 90s, you started seeing the JMS as a standard, standardizing some of the queue-based messaging, as well as something popped up called a publisher subscriber. So the queue-based messaging evolved into publisher subscriber based messaging, which allowed many applications to register for the interesting events and then process the messaging. So you can visualize again from simple queuing approach to the publisher subscriber approach of messaging came. And as the time goes, right, in the modern messaging system, you see that now all these simple things, messaging queue based as well as the publisher subscriber approach needs to work at scale, at cloud level scale. A lot of this cloud, we need to distributed workload is coming. In all the distributed workload needs to facilitate this messaging. So you started seeing things like Kafka and things like RabbitMQ to some extent started addressing those architecture. It's sometimes called event-based architecture. And then you would see the different layers of that or different flavors of that MQQT and zero MQ all popped up to focus a particular area of particular I would say domain of that messaging. So this is what we call a messaging system over the time, right? So it started from simple queue and then went into the distributed architecture, and then Kafka being one of the scalable architecture. So if you can, just put this in your mind, there is an application layer, there is a messaging layer in the beginning, and then there is a standardization came. JMS as one of the standard, I think with the advent of Java, then JMS came. So somebody tried to define the standardization behind this messaging system. So that's how the messaging system evolved. All right. I think this slide tells you how it's being used in other applications. Now, why are we saying that, right? You would start seeing a similar trend might happen in the agent-to-agent communication. So in the case of in the messaging-based systems, application, at the end of the day, the what we do is, most of them like microservices. Some microservices uses this messaging to communicate to each other, right? Uh, just keep that in mind. Then when we draw a parallel between that two agents, you will see the similarities and then differences. This is kind of a comparison table, again, to summarize some of you who are coming new to this, saying that there are different technologies, and then, what are the use case in which each messaging system is applicable, and then what is the protocol used. You start seeing that, you started using AMQ and HTTP based, and then MQTT based protocols supporting each different technologies. Then the more important thing is, you see these characteristics, delivery guarantees, scalability, durability. So each one has a different sort of focus, I would say that. This focus makes the application designer to choose, what is the right queuing tech or right messaging technology for their application. In some application, durability is important than scalability. And in some application, the delivery guarantee is important than scalability. So all these combinations, which then later turn into a CAP theorem, right? Some of you may be familiar with the CAP theorem. CAP theorem states that in a distributed environment, and out of the three properties, you can only achieve two properties. So I'm not going to go too deep into that. I just want to say that, right? This is very important for us to understand when we go and design how the agents are going to communicate to each other. So for that reason, I'm just introducing this theorem. So of course, you are welcome to read more about this theorem on your own. But just to say that when we think about agent-to-agent communication at scale, at internet level scale, we need to apply this theorem in designing our systems. So with that introduction, let me go back and what Cisco was trying to do. So as you can see in the slide, right, when we had an internet at the time, the transport protocols are TCP, obviously all this IP and stuff like that, that allows the computer-computer communication, right? That's the bottom layer. I think by now we all know that. Then came higher level transport protocols like HTTPS, SSL, which allows a higher level application to communicate to each other, right? And then what we are talking now is extending the same concept, right? Imagine agents is a important entity. Then agents is a true entity by itself. It's a it's a first principle on its own. Then it allows agents to agents exchange semantics that is called semantic protocols. It allows agents to agents pass on, I want to communicate to, for example, crew A from LangChain. Different protocols, different agentic protocol needs to work together. There is a syntactic transformation need to happen. So that is called syntactic layer. So what we say, in Cisco, there is a layer, higher level layer is coming, can be visualized in the new agentic world, in which it's better to see, instead of seeing agent application as a one entity, most of us in the beginning would always see, if, for example, crew A based agents, right? Crew A based agents or LangChain based agents, LangGraph based agents as one application level entity. Instead of seeing that way, let's see it in a three different levels, which allows you to even scale at a much better scale. What is that? I'm going to say. But the first thing is to realize, see it in a multiple layer, the agents. When you start seeing agents at a multiple layer, it allows you to do a better instrumentation for one of the layer. In Cisco proposal, the transport layer is very, need to be scaled up, need to support multiple protocols, need to have a low latency in some sense, in some cases. So we are defining the characteristics, the principles needed for the transport layer to become a scalable version. So that is one of the reason, Cisco wanted to see that as a three layers. Okay, let me go into that a little bit deeper. Before we go into the deeper, again, I'm not going to go into this CAP theorem, but I captured some information necessary for this audience. You can always go back and look at this PDF. But what I'm asking you to keep in mind, again, don't think that this is something evolving as we speak. From Cisco's perspective, we are trying to put together a forum. Again, when you see the next slides, there is Cisco is working with a lot of players, including the LangChain, in defining this, what we call Internet of Agents. Okay, so the idea is, how this scalable, this theorem CAP will be applicable to these three areas we need to keep in mind. Okay, this slide tells you where we stand today. Here, agency, for example, this called agency collective is actually from Cisco. That's a name given to the initiative. There is a website I'm going to follow, show you at the end. But this slide is very important. When somebody is asking, there are too many things are going on in the agents world, right? We can write a agents um, application quite simply. But when the MCP came in a few months back, initially, you know, it is MCP, as you know, it is not for agent to agent, right? It is for agents to use tools. So every protocol has its own focus. So this slide is trying to tell you, where MCP, one of the recent protocol, and agent to agent protocol, where they stand in terms of significance in the messaging layers or agents layers, and where Cisco's thought about the transport layer will fit in. So we need to think all the three things in together in putting together properly. So for that, this table might be a good way to start. First of all, the MCP, the primary focus, again, in this audience, I'm not sure how many of you are familiar with MCP. I think the audience, based on the meetup description, I hope who are joined are familiar with some of the concept of agents, right? A little bit of MCP, and of course, a little bit of A2A at the very high level. And if it is completely new word to you, you might see this presentation will be a challenging, but I assume you have some knowledge about these things. So the MCP is about agent communicating to a tool and getting some information, right? That's a focus. A2A protocol is about agent to agent. It allows the inter agent communication. It allows you to communicate between crew AA to LangGraph, things like that. So that's defined by the Google. Google and their partners, together with partners, they define the ATA protocol. Of course, in the case of agency, this is Cisco's version of a bigger vision, including the transport layer. We have been working with LangChain, Llama Index to define this agent's transport layer, right? That is Cisco's focus is slightly different. We don't want to be, Cisco doesn't need to be, are not interested in agent to model protocol. Its focus is not in agent to agent protocol. Its focus rather take your, whatever protocol you use at the, what we call semantic syntactic layer, but scale at the transport layer. So that is where the Cisco's focus. And scope is defined here, and then core interaction, you can see that architecture, in the case of MCP, the architecture is client host server. In the case of A2A, it's a client, two different agents are talking to each other, right? And then, of course, in the Cisco's proposal approach, which we are going to explain, there are concepts like ACP, Slim, directory, OASF. These are all the new concept or terminology being introduced, right? So we're going to talk about that. And the primary transport, that's one of the key thing, right? It's because one of the pitch from Cisco is to that, we transport layer, we scale better, right? But just in comparison, in the primary transport for MCP is HTTP, right? Sometimes HTTP stream. And then primary transport for A2A, it's obviously HTTPS and HTTP. But here, on the other hand, now, if you use in your agent application Cisco, then, we defined a new protocol called Slim. Slim is like you can consider as a light and thin version of HTTP, right? And that is a core strength of Cisco anyway, right? Go and look at all the TCP layer communication, UDP layer communication, and how do we reduce the latency. So the Cisco wanted to leverage that and then create its own protocol called Slim, which is a lightweight. Latency is not a problem. High throughput, all those things are fit into Slim. Not only that, that layer is going to give publisher subscriber, right? Queuing control and security. All the things are embedded in the Slim layer. And then Cisco is positioning Slim approach, the Slim component as one of the transport level components, which then allows efficient communication, and then agents directory, and then agents identity. All the things are going to be built using some of these components. The next slide is going to show bigger architecture, but I'm just introducing now. So that's the idea. The whole idea is, you can see the discovery, how it's actually discovered in the MCP world, how the host come to know server. You might need to, there are MCP servers coming, right? But still in your client side, you need to say which MCP server you are using. And similarly, agent to protocol, you need to do some at command to do that. So there are different ways to discover these services in its ecosystem. Okay, let's pause here. Why we are saying this, right? Why I'm introducing this. So the reason I'm introducing this slide is to give you some flavor of where the Internet of Agents is trying to fit in, right? Again, we are trying to be agnostic. So that's the reason I was talking about multiple layer approach, right? Syntactic and semantic and transport. Cisco really want to play a role in the transport layer of the agent's communication, and let, for example, Google or others also come in and play the role in the semantic and syntactic layer of agents. Okay, so who are the supporters or partners of this? These are the partners involved in together helping defining that what we call Internet of Agents. By the way, this initiative was, if you think about the timeline, right? When even before MCP, I think even before ATA, Cisco was proposing that. It didn't come to the limelight, but Cisco was proposing this. But later MCP and then A2A obviously came, and then MCP particularly quickly captured the market. But after that, Cisco went back and say, right, we are going to incorporate the MCP A2A in its own stack and then make it seamless. Okay, so with that some idea, what we are getting into is, at the end, I'm going to show some small snippets of code. I'm not going to show actual demo, but I'll show you how this is, all this concept I'm talking, how this is wired. So there are three things, this what we call agency. The brand name behind Cisco's Internet of Agents is called agency. There is a it looks like there is a typo, but it's not. It's meant to attract this brand name. So agency, it's called agency. So what is the agency's core components? One is allow agents to identify each other, discover and identify. That's one of the framework as well as open source implementations is created by Cisco. In other words, if you, for example, imagine there's a bunch of servers. You can host this server, discover server, and identify server in the internet. And then, if you're familiar with the DNS, DNS is a great example. It's very similar to DNS. DNS, who are, in order to publish your IP address and then your domain name, obviously you need DNS server. The way the DNS servers works, every corporations might have its own DNS server, enterprises, and then companies like Google, they also have DNS servers. So across the world, all the DNS servers are decentralized to manage decentralized way, and then exchange a new device, in this case IP address, coming into the internet. So that is a DNS world. Similarly, in agents world, you can imagine you set up this agent server in your enterprises, and then you set up agent server across the world, right? Like the similar way to DNS. Then agents can discover other agents. Say you're an enterprise, internally you developed thousands of agents. And these thousands of agents, some of the agents are company specific. So you can control these agents are enterprise specific. You still publish in your agent server. And then you can also say some of the agents I can give to my customers. It's a free, right? It's a, in other words, my customers can use it, those agents, for solving some of their problems. So you can have various levels of agents that you develop in enterprise to be distributed. So all these things are again put together under the discover and identity component of the Internet of Agents. And then security. Security is very important. Right now I don't, I have done CRUA and then LangChain, and I don't remember, the security is a core piece of this agent-agent communication, right? As far as I could remember, I can put all the agents in the CRUA, it communicates to each other. But in the real world, it's not going to be like that. Especially when the agents are going to be published at the internet level, internet scale level. You need to know each agents need to define some way to restrict itself to be called from other agents, and things like that need to happen. So there is a need of securely connecting agents to agents at the internet level. And then, of course, you have a similar need, observe and evaluate, right? And this is also needed. It's very similar to what you might know already. How do you evaluate agents at your laptop as it functions? But here you just take the concept much further. At the scale, internet scale, how do you observe and evaluate how your agents are being used? This is a goal, how do we incorporate all these things and come up with Internet of Agents is the idea behind this agency uh, consortium, right? All right. So, I mean, at the end of the day, if you go to a little bit light, let me show the websites and then we'll continue. The way you can get more information, go to agency.org, right? So it says what is agency? An open source collective for inter-agent collaboration, of course. Sounds good. And then if you go to GitHub, right, you can look at the repositories. I mean, you can, take your time and go. So the way it is defined is, for every, there are three components, as I was saying: discovery, identity, and then transport. And the transport meaning the Sling protocol. You would see that, of course, observe for all those 4 or 5 components, right? You would see the specification and then corresponding implementation. It is in the same style that Cisco used to do 30 years back. IEEE specification for a standard protocol, right? We publish the protocol, and then we work on a implementation, sometimes open source, sometimes proprietary implementation. In the same manner, these protocols are published. I mean, spec is published, and there is a product. I mean, implementation of this available. So I welcome you to go to all the repositories when you get a time. So, and then of course you go to the documentation, right? And there's a lot of documentations is there. Let's go back to the slide. So I think we have probably another 15 to 20 minutes, and I'm in slide number 20. It should go pretty fast. Okay. So we at this point, we need to understand a little bit deeper about the architecture. So this is the architecture of Internet of Agents. Well, in the way to read this architecture, in the left-hand side, we are essentially saying, this architecture allow you to discover, compose, and deploy. So discover meaning, when you're writing a new application, your application can discover new agents, right? That's called discovery. In order for you to discover an agent, prior to that, somebody has to develop some agents and publish it, right? That's exactly called OASF. I think Open Agent Standards Specification, I believe. So it's basically OASF is about specifying the agents in a JSON or XML format, JSON format, and then publish that to your directory. The directory could be your organizational directory. And then, as I was saying, Cisco's framework is taking care between agent directory to agent directory communication like DNS, right? That is taken care by the Internet of Agents architecture. So at your point level, you need to define that OASF properly for your agent and then push to these repositories. Then the distribution happens automatically. So now you have developed an agent and then you publish it, right? During the publication, obviously you will see security is defined as part of the OASF. right? And then in the next to that, your agents are running at the runtime. Now your code, the agents you developed, started running, and it uses a foundational model protocol and do all those agents, usual stuff we do as part of the agentic reasoning, right? As you do that, in this diagram, you see that agent 1 is communicating to agent 2. Similarly, agent 2 is communicating to agent n, right? And then now between agent 1 and agent 2, it's very important constant. If you understand this diagram, it's pretty much we got the Internet of Agents. So the agent 1 can communicate to agent 2 either using agent connect protocol, or it could use ATA protocol, or it could use, in the case of tools, it will use as MCP protocol, or it could use in the future, there will be XRY protocol, right? It doesn't matter. So between the agents, any different, protocol, uh, um, well, it could be same protocol or in different protocol. When I say protocol, I'm talking in the ACP protocol, right? Or ATA protocol. Can happen. So in order to facilitate in a different protocol, there is a need of IO mapper, right? So IO mapper allows you to map between one version of protocol to another version of protocol. Now, in this architecture, it's called IO mapper. I think, if you think about A2A, in this picture, the A2A is not shown. If you visualize A2A, it is what it does, and it's taking care of some of the mapping inside its A2A architecture. But in this diagram, since the focus is Internet of Agents, basically explicitly we are saying there is a ATA type, an IO mapper is happening here. Okay, so far good, but but the real secret sauce is for this architecture is coming in this SLIM architecture, secure, low latency, interactive messaging. So what this does, what Cisco is saying, we take care of this layer, which allows any number of agents at Internet of level scale to pass on, to allow them to communicate to each other, right? So, these agents doesn't need to go through the HTTP or in a GPRC type protocol. Rather, they redirected the transport, the communication through this slim layer. And then slim layer is, of course, it's a secure low latency. That means it is a different version. It is not a TCP or HTTP defined protocol. It has its own way of dealing with the connections and then with low latency at scale, which provides in the future quantum safe communication and also allows the secured way of communicating. So this layer is a key thing in this architecture. Okay, so it's very, one of the analogy I'm thinking about is, which may be a little crude, is about if you take the NVIDIA chips, NVIDIA communicating GPU to GPU, they use NVLink as one of the way to do that. Another way is RDMA. They access the memory directly between the GPU through buses. Those are all low latency sort of communication. They don't go through a regular networking layer. That, to speed up the GP communication, which helps you in the model training as well as mostly in model training, in some cases inference. In the similar manner, here this layer is taking care of low latency, because in the future, when the agents communicate between each other, it's not only going to communicate simple information. Today it might appear that it might pass some small context, right, in text. But in the future, it's going to send an image or video, in some way as a context. So you would see the need of the low latency, going much, much higher. So hence, when we think about future agentic, some kind of a common layer is very important, right? It's not only, low latency. Here, you can also add more thinking into that. One is, can we introduce publisher subscriber into this slim layer? What does it mean? That means when agents wants to communicate, as of now, we are familiar with agents communicating to one agent, right? How about agents wants to communicate to, like, publisher subscriber? It doesn't know for which agent. It simply is going to say publish, right? Send the message. It doesn't care which agent's picking up. So incorporate that publisher subscriber concept into the agent's communication. That's the reason I introduced the messaging before, right? We talked about the messaging. It went from simple queuing architecture to publisher subscriber and evolved into distributed publisher subscriber in the Kafka. So apply that here now. So now agents wants to communicate to each other agent. It wants to communicate the context. Sometimes it may be huge in the future. And then it wants publisher subscriber concept between the agents. So if you apply that analogy here, you would see, there is a big layer needed to make the whole Internet of Agents work. Okay, so that's a key message. The one message that I want to send it or say today is what it is. This diagram, right? That's a crux of this Internet of Agents. So we believe in the future, Cisco or Cisco like, there will be internet scale level latency reduced. Message passing is very important for internet agent to agent communication. Okay, the next slide I'm going to let you guys read later.
One
but
question.
Yeah.
In this architecture, do you anticipate like n:1 or 1:n kind of communication patterns? And will the slim layer actually also take care of like the equivalent of a multicast?
Yeah, that's a good point. That is what I mean. I don't. I'm also yet to go into that level details, but that's what it says. Specification says that. It says publisher subscriber. With the 1 to m type messaging needs to be applied.
Okay,
Right.
thank you.
Yeah. I'm going to skip that. So with that, the core message of today's meeting. The rest of them are examples of that. So there are two examples. One is in this example. How is a typical agent-to-agent communication work? All right. A simple agent, which has a LLM and tools, can communicate to another agent with the tools, right? And then, the other agent might have MCP as a way to connect to the tools. So this simple agent doesn't have MCP interface, MCP client, but this remote agent has MCP client connected to the MCP server, right? And then another version of that is this agent is talking to another agent where it connects to the MCP server, which MCP server processing also connects to, it's cascading. It talks to another agent, with the model and context. So, I mean, this is an example. It's nothing to do with the Cisco agency here. This is a general diagram of how agent-to-agent communication happens. But the next diagram, take that concept and tells you, in the other way to think when you are to realize the benefit of agency protocol SLIM. A supervisor can, as a supervisor is an agent, which can use A to A protocol. Remember, we are not saying that Cisco wants to play in the role of A to A, though Cisco defined ACP. But our goal is to say this layer of public, SLIM, the pub sub layer or SLIM, is the layer in which we scale, right? And then it can allow you to communicate between different agents. So that's what this diagram is trying to convey. So I'm going to skip this in interest of time. It's an open agent schema framework. You can look into that. Agent directories, again, we touched upon that. I hope I presented the need of agents directory when you're talking about internet level of agents. And then it's very similar to DNS approach where directories synced up each other at the internet level. That's called agent directory. Again, the specification is there. The sample or open source implementation is available. As you see, when these things get traction, you would see this becoming more familiar in the agents world. So that is called agents directory. But as of today, you can download and play with that. You can demo it. You can test it up. You can create a agents directory for your enterprise. And though it may not right now have internet level, DNS level sync up, but within your organization, you would be able to sync to directory servers. Things like that, you can test it. And Slim supports multiple angles to that. One is Slim is a low latency layer. It supports request response, and then publish, subscribe, which I told. And also it supports unidirectional streaming and bidirectional streaming and fire and forget. So the beauty about this, one of the selling point, I would say, is that when you develop your agents, right? And then in the agents, when you develop, you can specify in your code, as of today, I want, or in the configuration, you can say, I want these agents to use request response approach of communication, right? And then later you can change it to any of those things. So the interchangeability between different modes of Slim happens in the Slim layer. It doesn't, you don't need to change the higher level code for that, right? Because Slim itself became a separate component, right? Unlike your current way of doing things, and if you're developing a crew AI or LangChain, you don't have control over which protocol, transport protocol you're going to say. It's mostly HTTPS or GPRC. So on the other hand, that's the whole pitch of this, presentation. If you use Slim as a component for transport, you can come and tweak that at the Slim layer. Okay. And then other important is agent identity, right? So, well, I think this is also very important aspect of agent-to-agent communication. Today, I don't think any agent system like Crew AI, LangChain have any integration with identifying the agents communicating each other. That's literally doesn't exist in my opinion. Maybe there are workarounds to do that at different layers in your agent application. But as a framework, the agent identity is a Cisco's version is allows you to control agent-agent communication. So with the introduction of the OASF specification for each agent, and then at the runtime, you're able to verify that is one of the core aspect of this framework. Composition is very important. Again, the composition is how do you develop a new agent by incorporating the existing agent around you, right? I mean, when you put together the agents directory and then identity, all the things, when you do it properly at the architecture level, now composition, creating a new agent out of the other agents become easier. I think one of the foundational goal for this agency is to make the composition work. Then only it's like reusability. Then others can develop quickly, of course, new agents quickly. So that's the whole idea of this is one of the principal aspect of the agents framework. Facilitate, enable, creating the new agents through composition. We are almost come to the demo code, and I'm going to go through the snippets. I'm not going to execute, but I'll take you some example, few more slides, and then we can stop for QA. So, of course, you can go to this, if you go to agency, agntcy.org, from there you can navigate to documents and GitHub. Okay, what I'm going to do, this is just to give you an introduction, right? I mean, at least it's kind of a little bit of hands-on, though I'm not executing it. So let's say we want to develop two agents. One is weather agents and vibe agent. The weather agent. So in our example walkthrough code, these three agents, weather agent is going to communicate to the vibe agent. So weather agent basically talks to some LLM or something and find out what's the current temperature on that city. Right? It knows the zip code, or it knows based on your IP address, it figures out what's the temperature at that moment. And then it wants to send that message to Vibe agent and then say, here is my temperature. Tell me about something. What's the vibe? And then the Vibe agent says, something like this, perfect day for iced coffee, right? Something like that. So now it appears very simple program, right? Agent-to-agent communication. So you can do with the simple HTTP-based communication, or you can do with Slim layer, right? So our goal is to demonstrate, in this, it's not a great example, but it's to demonstrate using the agency library, how we can develop this agent. Okay, let's look at that. So this is how I know. I mean, basically, this is nothing but a copy of the instructions from the GitHub. If you go to GitHub, you see that agency, right? Agency and agency apps, and you see that there are more than 6 or 7 examples are there. One of them is the weather vibe agents. So you're welcome to read it, but at the minimum, I'm just going to walk through the minimum. I'll let you read and then experiment on your own. So essentially, this is how you do it. You clone it and go to agentic apps, and then you check out this weather, right? Weather app. I mean, this is a branch. Check out the branch. And then once you do that, you would obviously see code like this coming, right? Testing and tutorials. And then here is how the weather vibes agents are looking like that. It's kind of internet is slow here. At this moment, I'm in SupportVector office. There is a small internet issue, but you see the agent, right? I mean, this is how it's going to work. So without going too much into the code, I mean, I'm going to show some part of the code here, but you can go into this GitHub and get more information. So first thing is to run 2 agents, right? This agent called weather agent, we make it run in port 52001. And WFSum is its utility come with this package. I'm thinking what's the name of that? I really forget what is WFSM means. Okay, so I need to go and see. But this is a tool which allows you to run this weather agent, right? And we are right now running the weather agent from this configuration file, right? So in the configuration file, of course, you will see all the details about the agent. What is the what is the remember we are talking about 3 layers. What is the protocol, semantic layer, syntactic layer, and then transport layer. All those things are specified in this agent, sorry, in this configuration file. And then right now we are going to run with the HTTP as a transport mechanism. Though you're not specifying in the command line, it's already specified in these files. But then, of course, then you're running this from command line. You're running, basically, you're communicating to the agent. Now the 2 agents are running. This is like client to the agent. You're connecting to this agent with the port number 52201 and simply asking the question, basically saying, this is my city, right? All you're saying, this is my city. And then you're asking the other side of the agent, Vibes agent, as interface command line, and see you as soon as you connect to that, you give that input, it gives the perfect day for iced coffee. So this is an example of simple example, very, very basic example, right? So let's see. What it says is, in this example, it's very trivial logic, demonstrated how agent output is passed to another agent. And it's a pure HTTP example. No additional systems are required. So these are, we are trying to illustrate, the uses of simple example with a complex one, which is a slim. Next is a slim example, right? This is the main program. What you're seeing is a command line based sort of the program. And curl can be used as you guys probably know that, right? As an interface to connect to server, any service, and then get the data. So this version, item 3 are list task 3 and task 4 essentially same. One thing is Python, other one is a command line based approach. All right. So this is the demo to show, or steps to show how you write a simple weather application, weather agent and Vibes agent with HTTP as a transport mechanism. Well, that is nothing exciting, but next let's go to the Slim-based approach. The Slim-based approach is slightly different. So if you recollect what is Slim provides, Slim has another architecture layer, right? If you go to the diagram, if you go to the diagram, Okay. Slim is another architecture layer. So that means what? It's another server. You can visualize there is another DNS like server, or enterprise will set up a Slim layer. So what you're doing, instead of you talking to agent through HTTP, you bypass the message, send the message to the Slim layer. And then Slim layer will take care of communicating back to the other agent. As simple as that. So that's why what you're saying in this Slim based connection approach, right? We all know Slim is going to provide much scalable internet level, and then quantum safe communication, all those things given coming with that. But from our programming perspective, you're creating a gateway. Essentially, you're saying, I'm going to connect to this gateway. Somewhere here in the agent, you're creating a gateway, and the gateway will connect to the Slim server. So in the gateway dot configuration file, you're basically saying this is my gateway, and then you're connecting to the port through 9443, and there are some tokens you set, and then you're basically saying route. Route means from here, right? If I get a message from agent 1 and pass it to the agent 2, those kind of configuration you're saying in the route. This is a configuration file that you are creating to enable the gateway for your company. And then you deploy the gateway. The WSM is a utility at your enterprise level, comes with agency software to deploy your gateway into instance running on that. And then after that, the whole idea is once we have that gateway is set up, from your code, all you need to do is create a client and then connect it to the corresponding host 9443, because imagine your gateway is running in 9443, and then with some authentication token, that's all you are saying. And then let existing code, the way you connect to the other agent, remain as it is. And then you will see this system is able to communicate to other agents through the Slim layer. That's what this code base is trying to convey. So when they design this communication, remember, you still, with this approach, you are still allowing to use A2K protocol. You still can use ACP protocol. So, but only the underlying layer you are enabling, instead of HTTP or anything GPRC, you are allowing the gateway to take care of that, transporting to the next agents. So with that, a nice way to integrate smoothly. In order to do that, they have to do a lot of work. At the code level, they need to make sure ACP protocol still goes to this layer, work as it is. So there is a lot of hard work in implementing the Slim layer, adopting or conforming to the existing existing HTTP layer supported by the ACP and ATA. So that pain is taken care within the agency and the code base. But for the end client, it's very transparent. In the previously, what you used to do, except that you communicate to the gateway, which takes care of the all the specification that Slim is defined. Let me pause here. This is the important snippet, right, to demonstrate that it is a seamless integration for anyone who is going to write agent-based application to use the slim based low latency based transport as a mechanism instead of regular HTTP mechanism. Let me go back to slide, and then I may be reaching the end of the slide now. Then we can go for a QA. In this, you have the repository, and then with the Slim, we achieved, built-in streaming, right? With that Slim coming in, then you can configure the Slim for publisher, subscriber, and then streaming mechanism, things like that. You can configure the Slim without changing the code base. All right, this is a final slide. So the takeaway is, that we reviewed the Internet of Agents, and today's topic is to take that one of the industry, right, a framework, which is the agency from Cisco, and then reviewed its concept called Internet of Agents. And then we talked about multiple components of that. Slim is being one of the primary transport mechanism, which allows one to scale, and then allows you to build directory services, agents directory services, as well as you can imagine, more and more security can be built as part of this framework, which then client level agents can have a simple way of handling these things, right? And then we talked about how it integrates with other systems. The goal of the agency and then Slim and then all the Internet of Agents protocol is to seamlessly work with the existing higher level protocols, not the transport, the semantic and then syntactic. Yes, I think I didn't go a lot of details about what is semantic and syntactic, but essentially it is, nothing but the following. A2A and ACP communication is called syntactic. Now, how each protocol talks to other protocol is syntactic. Semantic means, what are the context and what are the model, what are the history, what are the knowledge I have. Is that, the way I understand between the one agent and other agent is different or same. That is called semantic conversation or semantic modeling. So, we let higher level layers to deal with, when I say we, it means, ATA, to deal with this semantic and syntactic. But Cisco is taking care of the other aspect of this Internet of Agents. I shared some examples in the GitHub. You're welcome to see that. Thank you. With that, I will end the session, but I'm going to look at the QA here.
Thank you, Krishna.
Yeah.
I have a question.
Yeah.
In terms of structure and the layers for the transportation.
Yeah, I think the voice is not clear for some reason.
Okay, let me.
Hello? I think something broke, yeah. So meantime, I'm reading Pradeep Jain. I believe it is architecture. Yeah, someone asked, is Slim mostly a publisher subscriber? Yeah, seamless communication. And it allows others as well. I was sharing on another slide. Slim takes care of 5, simple publisher subscriber, simple queuing, and then streaming, one directional streaming, multi-directional streaming, and then fire and forget. These are the 5 modes it supports. I mean, otherwise, there is not less value for Slim, right? It's supposed to support all the formats so that, for applications can use it what they want it. Okay, that's how I see the question. Yes, I will publish the PDF and the recordings will be available. Any other questions?
Yes, if there will be, do you hear me now?
Yes, go ahead, please.
Yeah, if there will be a payment layer or like a way for those agents to send and receive payments, in
Yeah.
which layer do you think something like that could happen? What's your
Yeah.
opinion?
Yeah. I don't see that at all in this definition, the payment layer. But if I have to visualize, I mean, so far it is not part of any spec, right? I mean, if you go to the directory, I don't know why the payment layer has not come. But you do see observability layer. I didn't go too much into that. Monitoring and observability is one of the big layer in this Internet of Agents. I'm not sure whether, from that observability and monitoring, right? And data points will be taken out, and then payment layer will be integrated. So I don't know, but that is your good question. How do we integrate payment layers as part of this?
Yeah, I watched a webinar today with Coinbase, and I think they're working on to do like a payment layer, and they're gonna use HTTP for and they will activate actually 402.
Yeah, good. And I think you gave me good. I'll think about that. That's interesting.
Yeah, it's probably gonna use, I mean, their like stable coin or.
Yeah, definitely.
So with that, I don't think we still need
Actually-
like identification if we build, I mean, for people who
Yeah.
going to build this layer.
Exactly. The agents can, some agents, let's say you're writing in agents, right? You are saying if you want to consume my agents, I want to somehow add a payment layer to that, right? I want to monetize my agents natively. So that's a good thinking. So then as I develop my agents and I publish it in the directory, the payment details are enforced on that.
Exactly, and then it's probably even more secure because hey, if you want to like communicate with this agent, you're probably either going to like use data from that agent or use something, and
Yeah,
to interact and you use anything, you probably need to do the payment fraction for whatever you are using.
right.
Pay to use.
Yeah. So I will take a look. I have not seen myself so far into the documents, but thank you for bringing that up. Okay. Thank you, guys. If you don't have any question, thank you for joining. So we will try to host similar, topics, every Monday. Hope to see you guys again. And Samantha, do you have any comments?
No. We're
Okay.
good.
Yeah. And by the way, the team, most of you are aware